All right, we're gonna get started since it is 1 o'clock, and we're right after lunch, so maybe there'll be some stragglers, maybe not. Either way, I think it's a session where what we want to do is talk about not so much focus on some of the concepts of raster analytics. We'll go through that just a little bit, but focus on the different ways that we expect, or we recommend that people. The way they work through using raster analytics, and just presenting all those options of different ways to consume raster analytics. So just to start out with, we'll just set the context right, just so you're very clear on what this is. If you haven't attended the sort of intro to raster analytics type session, raster analytics is the way that that ArcGIS executes distributed analytics on distributed storage. So it's a system where it requires ArcGIS Enterprise and ArcGIS Image Server. Okay, so if you wanted to do distributed analytics, you must have ArcGIS Enterprise and Image Server. Okay? And from an overall perspective of what things you can do with it, there's a lot of functions that you can use in the system. Each one of those are single functions for raster analytics. Right? But all of those can be modeled into models. So you can build a model combining functions to process either GIS rasters or process imagery, right? And so you can combine all those together, make models and submit those models, or just use single functions. One of the more interesting ones we always like to point out is the one on the far right, which is the Python function. And the Python function allows you to write custom algorithms. So if you don't want to use any of these functions and you want to write your own algorithm in Python, you can do that, and we can inject that into our framework so that it will distribute that particular Python processing inside our system. Okay? So it's a way for you to write custom algorithms outside of what we have. Okay? So there's lots of stuff there you can do with it. In terms of how the basics of interaction with raster analytics, there's 3 primary ways that you interact with it when it's configured. You either use ArcGIS Pro, which is you do your design and your modeling inside Pro, and then you have Pro send the request to do the processing to the enterprise system, or you may develop something in Pro, publish it to the portal, and consume it from within the web experience, right? So we have the case of interacting with raster analytics through the web, both through predefined analytics that come out of the box, as well as the ability of Pro to publish those analytics to the web for consumption. Finally, there's the researcher, explorer, developer workflow interaction, right? And that is through the ArcGIS API for Python. So if you're interested in doing more of a programmatic approach or automation approach to working with raster analytics, you would do that by using the ArcGIS API for Python. I think you're going to show some of that as well, right? Yep. So Jay will show some of that. So let's talk about just from the way that we can define some workflows. So if you think about how I should use raster analytics, there's basically 7 main ways that you use raster analytics. The first is you just use Pro with out-of-the-box analysis, right? You basically use pre-baked functions that are already in there. You open up a web image layer and you say, create me a new web image layer, and it all happens, and you didn't really design anything, you just use things that were already there. An example of that might be, I want to run NDVI at scale to a large raster or a collection of rasters, right? Because we already have an NDVI function, you would just submit it to the server and you could process. So that's sort of the out-of-the-box analysis. The next workflow is using Pro for custom analysis. So that's basically things like, I'm going to use the raster function editor, visual designer inside Pro, design my own model and submit it to the server. The third is using Enterprise out of the box. That's pre-configured analytics through the web experience in the map viewer to run analysis. The next is custom. We'll talk a little bit about that as well. That's similar to the Pro custom analysis. How do you actually do that? By publishing from Pro. And then we'll go into the Python for developers and systems integrators, how you would actually work with that, which is a little bit different than how you use the ArcGIS API for Python and Jupyter notebooks, right? Even though they both use Python, one is used primarily to automate a system, which is we have a sensor bringing down data, and we actually want to put it in the system and process it every day or every hour, and we want to automate that. And that's much different than more of an exploratory look of using ArcGIS API for Python and Jupyter notebooks, more of the scientific exploration workflow. And finally, for those people who are sort of hardcore in the web development and are not Python developers, there's also a way, the server comes with a fully enriched REST API to write your own web apps in front of the Raster Analytics. So just real quick, like I said, ArcGIS Pro out of the box is basically this notion of you can use, the pre-baked functions in the raster analysis pane. There's also a set of GP wrappers around pre-baked tools where you can just run it as if it's a GP tool, but it will actually execute on the server. It's basically a GP wrapper around calling the server. Those actually, there's a whole set that will run locally, but in terms of running distributed, there's a drop-down pane that has a set of pre-baked tools. So that's sort of out of the box. Just go ahead and pick one of these functions and have it run on the server. Pro custom analysis, like we said, it basically, when the way it works is that when you design a function in the raster function editor in Pro, right, once you have your model, the user experience allows you to decide, do I want to run that locally first, look at the results on the fly, right? And once I QA it and look at it, I might want to submit to the server on a larger data set, right? So the way that's done is, Jay will show you, is that basically it's the type of layer that you create. If you create a normal raster layer, it's going to run locally on the fly. If you create a web image layer, it's going to run on the server, create a persistent data set on the server, and build you a layer pointing to that layer on the server. And that one's going to run at scale, okay? So that's more of that's basically the workflow for doing web image layer. I think it'll be much more clear when Jay does some of the demos. Okay? So we'll switch over to Jay, and he's going to walk through the workflows related to ArcGIS Pro.
All right. I think we forgot to introduce ourselves.
That's okay.
Mike Miller. Okay.
It's on the slide.
Yeah. Okay. Hello, everyone. My name's Jay Z, and I don't rap. So I'm a product engineer. JC. I don't rap though. I'm a product engineer in the raster development team. So in the next part of the session, what I'm going to give you is a demo to showcase how you can use Pro as your client app to build up your Raster Analytics workflow. So as let me just exit the slide now. So as Mike mentioned earlier, you have, in Mike's previous slide, you have a rich set of raster analytic functionalities that is building into the ArcGIS product. Pro is the go-to app for you to access all these functionalities. If you started Pro and open up the raster function pane under System tab, these are all the pre-built raster functions that we integrate into ArcGIS Pro. So before I continue, may I get a show of hand? How many of you are familiar with the concept of raster function? Only a few of them. Okay. So basically, just raster function is, if you're used to the concept of geoprocessing always takes certain input and process the data and spits out a persistent output on your disk, right? And raster function is specifically designed for raster data analytics. And the one special thing about this is it can generate the on-the-fly processing result for you to preview the analytic result, right? So in this particular example, I'm going to use some pre-built analytic functions and then try to generate a workflow to process this Landsat 8 imagery that I shared on my enterprise GIS, on my image server, basically. So what I'm going to do is, first of all, this Landsat 8 imagery has these black borders around it. So I'm going to search for a pre-built raster function that does the masking of the no data pixels, black pixels around the imagery. I'm just going to choose my input. As you can see, to apply a raster function, you simply click on it, and it brings up this interface for you to assign inputs and all the parameter values. So this is the 8-band image. I'm just going to give the pixel value that I want to set as no data, which is 0 for all the bands. And then I want to make sure the way that I mask it is mask match all, meaning only if a single pixel that across all the bands has the value of 0 be marked as no data. So as Mike mentioned earlier, depending on which type of output layer do you choose, will decide whether the output you're going to create is going to be a in-the-memory, on-the-fly layer or a persistent layer that the server is going to be processed and shared on your portal behind the scene. So in this case, because I'm building a workflow, so I'm just going to create a temporary layer now, choose raster layer type of output. As you can see, the mask function automatically mask out all those black pixels around it, and you get the on-the-fly processing result right away, instantly. And again, I need to emphasize this is an in-memory layer. This is actually not a data set that we generated on the disk. And next step I like to do is I'm going to apply a vegetation index analysis on this data set, on this mask data set. So the function I'm going to use is band arithmetic. And the index raster that I'm trying to create is using the mask raster as input, and I want to compute this modify savvy index raster, modify soil adjusted vegetation index raster. And I know the Landsat data, the 5th band is the near infrared and 4th band is the red. Again, I'm going to create another on-the-fly processed layer just to preview the results. And I have a modified vegetation index raster created here. Again, another virtual layer, which has the mask applied on it already. Right, so I'm going to speed up, and next few things I like to do is I want to remap the pixel value. Basically, the index range is from -1 to 1. So I'm going to say -1 to -0.6 is 0, -0.6 to -0.3 is 50, and then -0.3. Yeah, just to get a better classified result. And then 100.
So Jay obviously knows the index and he knows the value range, right?
Yeah.
So it's just something you could go look up and see what's the, and each type of index produces a range, and you can, there's documentation you can read that sort of tells you the, things in the real world that potentially appear in ranges of the index.
Yep.
I think the other thing I'll note while he's doing this is that if you bring up Pro and you go to output layer type and you don't see the option to create a web image layer, that tells you that you don't have a portal that has Raster Analytics configured.
Yeah, that's what I'm
that would be, it's not mysterious that it's not there. It's because your portal doesn't support it. You have to have it configured to support Raster Analytics.
So I have my raster remapped. The last thing I like to is just to give it appealing color map to generate the final result. As you can see here, by generating each temporary layers in my map, I'm actually building up a workflow with multiple functions. I'm feeding the result of a previous function to the next one. And then in the last step, I'm just going to choose a color ramp. And here we go with the red to green. So what you ended up with is a analytical result that I will eventually produce. Right? As I mentioned earlier, this entire workflow is actually a raster function model behind the scene. Right? So if you right-click on this virtual layer in your map and go to pick this option as edit raster function, edit function chain, you have this new interface showing you all these functions that apply on this raster, right? And you can save this the function chain as a function template by clicking the Save Function Chain options. And click on the Save button. Then this is actually a process of generalizing your Raster Analytic workflows. If I can pull, if I can pull it over. Okay. Savvy, and then just say demo, right? And all these save the template, you can decide in your project where you want to save them to. You just click OK, and then the functions chain that you save through ArcGIS Pro will become a file with the extension of rft.xml. This is what we call the raster function template file. If you go back to the raster function pane, and you can find the functions that I just saved here, right? So this is just the process of generalizing Raster Analytic workflows. So you can apply the same processing on any other new data that you may come up with later on. Right, and then it's also another similar concept, another similar things regarding the function chain comparing to GP model is you can expose certain parameters as the public parameter for this function chain. For example, in this case, I like to expose the raster parameter, save this chain, and then when I open this function chain, it will ask for the raster input of this workflow. So if I'm applying to the original data that I was using earlier, and it actually, instead of creating multiple temporary layers, it applies the entire chain and create a new layer, right? New on-the-fly layer, right? So this is the local on-the-fly processing workflow, as Mike mentioned earlier in his slides. So if you have a ArcGIS Enterprise configured with the raster analysis image server capability enabled, and you sign to this portal, this Enterprise GIS, you will see the option like what I did here. This is actually a portal that I deploy on our AWS account, under our AWS Amazon account. And you sign into this portal here, and then you will have, anytime when you apply a raster function or raster function chain, you see the options to determine how you're going to run this function. If you choose the raster layer, it's going to create the on-fly locally processed temporary layer. And if you choose the web imagery layer, it switches the mode, and it's actually going to send your analytic models to the server behind the scene, also including information where to access your input data, and that the multiple server machines to process your imagery, and automatically share the output as a web imagery layer in your portal as an item in your content. And then if you choose this option, there are additional settings you can change. You need to give a name, give a description, give a summary. You decide whether you want to share it to somebody else in your organization, and there are certain settings as of you can change the output projections, extend how you want to snap the raster. You can even decide what kind of resolution of output you're going to generate. The output is a persistent data set. It's no longer a on-the-fly processing in memory layer, right? And so here I'm just going to say that, let me zoom to the bookmark here. Just for the sake of time, I'm going to process this imagery under this extent, and I'm going to save to a particular folder here. Oh, sorry. Actually, let me just save it here. Yeah. And I'll say I want to run based on the current display extent, and just run it. Right. So by clicking this run button, all the information is being streaming to the Amazon server. And because my input is already a shared image service in my portal, in my Enterprise GIS, so the server knows where to access the data, right? And because the Enterprise GIS is distributed in nature, so this image is being split into small chunks, and each chunks are being processed with a worker thread. So the image, the persistent image, output image will be generated faster. And you can access, while you're running this process in your enterprise, you can actually access the history or the progress information under the History tab. And if you go to the Catalog window and the History tab, you can see there is a function running. Oh, I actually made a mistake here. Yes, I forgot to assign the input. Yeah, I have to assign the input. Okay. And this time I forgot to assign the extent. Okay, you get the idea as of the data set will be processed on the server and with multiple server instance. So next I'll hand it back to Mike.
Yep.
And you're going to keep on talking about enterprise story. Okay.
So I think the key takeaway with Pro there is that you're going to, in those particular workflows, you design within Pro, you use on-the-fly capabilities to preview, look at the results, develop your algorithm, develop your model to see if everything's good. You can preview that even on large data sets, you can pan and zoom around and look at different areas, and not worry about that initial cost of taking a while to produce it and then looking at it and saying you don't like it, right? So you use the on-the-fly mechanism to actually, as a QA mechanism, and then when you're ready to create a final persistent result at full resolution, you basically submit it to the portal through Raster Analytics and generate the product and do it at scale and use multiple servers. So it's a workflow where you sort of combine the on-the-fly with the persistent nature of Raster Analytics. Now we can talk a little bit about just doing that without ArcGIS Pro in this case. There's and somewhat of a combination of Pro for publishing, but in terms of just doing it via a web browser through the map user experience in enterprise. So the way that's done is, one model is you log into, your portal, you create a web map, you use a imagery layer or a raster layer. Your portal is already configured your enterprise portal is already configured for raster analysis. You go to the analysis button inside the web map viewer experience and you want to run an existing tool that Esri's already boxed up. That's a case like monitor vegetation, which results in being able to do things like NDVI against imagery without having to build it all yourself. And there you just go through the web experience of finding the tool you want to use, invoking it. It gives you a web form experience for filling in the parameters. And you run it. And everything happens on the server, and the result is a web image layer. So that one's pretty straightforward of just using a complete web experience of functions that Esri's already packaged up. The next is how do you actually do custom analysis for the browser. The way that happens is through this notion of sharing that RFT XML file that Jay showed you, right? So the idea is that you author a model in Pro, you think it's a good model, you want to share it with other people, or it's a model that's repetitive against other imagery. You share it via Pro. It becomes an item in the portal, a full-fledged item that's searchable with metadata if you want to tag it with it. And then we have a new experience for browsing and searching specifically for those types of models. Jay will show that. And the cool thing is that the model is your model, but our system is designed that when the person who runs it invokes it, we actually look at the model and generate a web form on the fly. So we'll actually create the user experience automatically for you. So you just describe your parameters to the model, and we'll actually build the web form on the fly. So it's pretty cool in terms of flexibility, which is you can make it, 1 parameter, 2 parameters, 3 parameters, 10 parameters, and we'll go ahead and inspect it and build the web form for you. Okay. One thing that's pretty exciting is what's going to be coming next. This isn't there today, but that's actually a screenshot of a running system on a dev machine, right? That the idea is that the same raster function editor that's in Pro is going to be in the web. So you'll actually be able to do visual design of those same raster functions completely from the web browser without involving Pro and run it all within the web experience. Right? So you won't actually need Pro to do some of this if you're a user. What's exciting about that is that the natural evolution of that is to put that on ArcGIS Online so that you can just have an ArcGIS Online account, log in, design models and run models with nothing on any machine installed, right? Which is a cool direction in terms of where we're going with some of this analytical work. Okay, so that's sort of a futures work, just to keep that in mind. That will be a future workflow in addition to custom analysis. So we'll switch back to Jay again, and he'll show you what we just talked about.
Right. Oh, it comes back. Okay, I just want to show you the result I was running earlier. And now that the persisted output of my M-Savvy index computation has been generated, you can actually find a service, actually an image layer item created under your portal. You can bring it into the map, and it's a persisted image service that is published in your enterprise GIS.
Right, so the end result of the analysis you run, that data set, just to be clear, right, that data set is living on the server in the distributed data store, already published as a web service without him having to do any of that.
Yeah.
So Raster Analytics is designed so that there's no publishing workflow in terms of the results. Everything you create through Raster Analytics, the system behind the scenes creates items in the portal, makes web services for them. You don't publish. It's already there, right? Which is pretty cool, right? And the reason behind that is because if you want to process at scale lots of images, who would want to sit and actually publish 5,000 images after you process them, right? Nobody wants to do that. You want the system to automatically create the items in the portal, the services, everything's already there by the time you're done with the analysis.
Yep. All right, so next thing I'd like to show you is the web map user experience to perform raster analysis. Like Mike mentioned earlier, if you have a ArcGIS portal with image server configured properly with the raster analysis capability enabled, if you go into the web map, you see this analysis button. You click on it, and you see this additional options, raster analysis options that contains a list of built-in analytic tools that you can choose to use. Right. As of today, this is the list of tools that you can directly apply on your imagery layers that is shared in your portal. And let me just run an example here. What I have here is a DM image of Charlotte, and I can just go to analysis if I want to compute a aspect analysis on this elevation data set. And click on one of these analytic tools, automatically expand and generate the user experience for you to assign inputs and if to give additional parameter values if there's any you need to do. And one thing that is different to the Pro demo that I showed earlier is in WebMap there's actually not yet a capability for you to preview the result. So when you are running, when you click this button to run analysis, it actually runs the it actually invokes the backend services to generate persistent result in the distributed data store and share them as image service right away. There's no preview steps here. Right, so let me just run this analysis, and a new layer will be created here, and with a spinning icon. So that means the backend service is crunching the data and generates the output for you. And I actually have a result generated earlier. Let me just hopefully show up faster. Okay. Yeah, so this is basically the same thing that I showed earlier in the Pro demo, a hosted image service that is generated by the raster analysis image server distributedly and automatically published as a image layer item in your portal. Right, so these are using the built-in analytic tools in the web map. There's also this capability, this little icon, to search for any function template that is shared in your enterprise GIS, right? For example, let me switch back to Pro. So I have another suitability analytic model here, which uses the entire United States land cover data, rainfall data, temperature data, and slope data. And I develop a raster function model that try to find the potential suitable solar power plant site across the entire United States, right? Let me just enlarge this. Right. So basically, this is a workflow a custom workflow that used all the building raster functions, just connecting them together. Right? It takes in all this imagery input, compute slope, and remap the value of the pixel to certain categories, and multiply a factor, and then adding all these different variables, conditions together to generate a score to decide whether this pixel or this location is most suitable to build a solar power plant on. Right? It looks fairly complicated, but actually it's a workflow that uses all the building functions. And I have this model built. Now the next thing I would like to do is I want to, obviously you can just simply apply this raster function to preview the result of your analysis. Right? And the red areas are the most suitable place for power plant. And then you can share this template if you right click on it, and there's an option called share to portal. Right? If you remember earlier that when you're constructing the raster function template, it's essentially a rft.xml file. It's a function template file. You can upload this file to your portal, and it becomes a raster function template item in your contents. Right? Let me just say test, share. Right? So after the template is shared, going back to your content, just refresh this. And you see a new item type being created here, raster function template. And you can bring in this raster function template in your web map. Let me switch to this one. And under the analysis, and click on this hidden button here. And then can search for the ones you're looking for. Solar, not polar. Yeah. Okay. So I shared multiple ones earlier, and just select the template. Oh, actually, when I shared it, I actually forgot to expose the parameters. Let me choose another one that I had earlier. This one should have the right. Yeah, okay. So this function template actually exposes all the input parameters for you to assign later on. So it automatically generates this user experience based on what kind of parameters you choose to expose in the function template. So you can assign the input, the image layer that you shared in the same enterprise GIS, and temperature. This is the land cover. And this is the rainfall. And let me just, because this is a fairly big 30-meter resolution United States image, let me just zoom to the area. I know Salton Sea is really hot, so it must be suitable to build a power plant there. Right? And then I can just run it. I click run analysis, and then it sends to the backend server, and generates the result using a distributed server instance. Yeah. So yeah, that's basically the capability of the web map nowadays. As Mike mentioned, we're also working on this web user experience for you to combine building raster functions to build your own custom workflow, and that is coming in the next enterprise release. No, next week? No, not that fast. Yeah, the next week is 10.6.1. So everything I show here today is what we have in 10.6.1. Yeah. The next one will be 10.7, which is
might be 10.7.
Might be 10.7.
Anyway, I think the point would be it'll be the release that's the end of 2018. So we typically do 2 major releases per year. So it'll be the one in the fall. That's when it will. That's when it will go out. I think what's really important about this workflow is the fact that it's an enterprise concept, right? So the idea is that you can have scientists and other analysts create models, share them to the portal, expose a minimum number of public parameters, so that all the users that consume data and look at data or want to do that simple analysis in different areas can actually understand very few parameters, and it builds that user experience on the fly for them, and they just pick their 2 layers or their layer, and it can run a complex model behind the scenes and give them the results that they're looking for. So they don't have to be the expert, they can just be the person who runs the tool, picks the inputs, and they're good to go, right? So it's a pretty powerful workflow in terms of, especially it being in a browser, they don't need to install Pro, they don't need to understand how to get bootstrapped into desktop GIS. They can just use a web experience and run basic analysis on their area or their layer that you've exposed to them.
Okay. Back to you. All right.
Yep. Mm-hmm. So let's go with the last bucket of workflow, and that is how do Python developers and systems integrators actually, what's their workflows, right? So one of their workflows is basically the ArcGIS API for Python, like we talked about. That's the notion that, is everybody familiar with the ArcGIS API for Python and how it's different from ArcPy? Okay, good, right? Because sometimes it can be confusing because there's more than one Python API, right? So the ArcGIS API for Python wraps ArcGIS Enterprise as a whole. And if you look right there, it's just a screenshot of the documentation. So what you want to look for is there's a new module inside the ArcGIS API for Python called the ArcGIS.raster.analytics module. That's where you're going to find all the APIs to work with the Raster Analytics system, right? So you can go ahead and look through that. That's how you can integrate with other systems, automate stuff in the background. You don't necessarily need a user experience for it, or do exploratory through the, basically just wiring into it for other systems so that you're processing using the servers, but not necessarily making a UI per se, right? The other is this notion that we talked about when I showed that graphic of all the functions, right? So you can also just use Python to develop your own algorithms, right? And the way that you do that is you create a simple raster function chain like Jay was designing, but you just use a Python raster function in it, and that Python raster function points to a Python module, and then you write the code to process the pixels yourself, right? So what will happen is that the system will feed you blocks of pixels, and your only responsibility is to do something with them and give us back a new block of pixels. We don't care what you do with them. Right? So it's very open-ended in terms of algorithm development, which is we give you a chunk, you give us back a chunk, and we can inject that and distribute that in the system, which is pretty powerful, right? If you want examples of that, we have a GitHub site where there's already some pre-built ones that you can base off of to see how they're built, what the code looks like, some explicit examples. That's that GitHub Esri raster functions. You can go look at that. That's completely open, and people contribute to that. So it's a good way to get bootstrapped into how do you actually write them to go along with. And there's documentation there that explains it. The other Python notion is basically, or developer notion is basically more of the Jupyter Notebook, more of the exploratory. That actually is using the Jupyter Notebook experience with the ArcGIS API for Python. In that one, you can actually use both. So you have the same workflow that you have in Pro in the sense that you can use on the fly to preview your results in the Python notebook before actually submitting it. And then once you decide you want to do it at scale, you can go ahead and use the Raster Analytics module to submit it to the server to do it at scale. right? So you have both there in terms of flexibility in using the Python/Jupyter Notebook approach to it, okay? And then, the last sort of, I mentioned, last option for developers is to go a little bit deeper for web app development, right? So if you don't want to use the web map viewer experience, and you don't want to use Pro, but you want powerful distributed analytics behind it, and you want to write your own web app, you can combine the ArcGIS JavaScript API to build like the map control, to build and use the widgets, and then you can dip into the REST API of the server for raster analysis. And that's basically the way that works is you basically, that model that he built in the raster function editor, all of those models, even though it's called RFT XML, all of those models can also be described in JSON. So you basically programmatically create JSON as a representation of the model, and then you submit that model to the server as a big chunk of JSON and with a bunch of parameters to deal with the inputs, outputs, etc. Right? Okay.
There just want to mention there's doc for that REST API as well. I will show you an example.
Okay. Yeah. Okay. So we'll just sort of flip back to Jay to cover that.
Okay, so one of the last demo that I'd like to show you is developer demo, both utilizing the ArcGIS API for Python. And if we have time, I'll go through that REST API demo as well. So for those of you who haven't used ArcGIS API for Python before, just a brief introduction of what it is that this is a set of API that is designed to work with ArcGIS Online and Enterprise. It's different to ArcPy, which relies on your desktop apps or engine setups. So if you go to the site and look up the document, it has a lot of information explaining how to use it and how it tied up to the Condo package index, how you can install it, set up on your own machine. And the API reference also contains a lot of information about how you can invoke analytic functionalities in the ArcGIS API for Python to perform distributed analysis. Basically, we have ported all the functions that is available in Pro nowadays as separate methods under this ArcGIS API for Python. You can find them all under the functions namespace, right? So this particular example I'd like to show you, if you have attended other Raster Analytics session, you probably have already seen this. So I want to show you an example that how you can script the process of constructing a custom analytic function chains using the ArcGIS API for Python. So just in this particular example, I want to construct another suitability analysis model that finds the best site to build a vineyard using a digital elevation data set that covers the Napa Valley. Right? You all like wines from Napa Valley. So let me just import some modules that I need to use. And I have to make a connection to my enterprise, to my portal that has image server with raster analysis enabled behind the scene. And then I can use the API to search for the data that I want to use as input for my analysis. So I have a image service published earlier, which is called the Napa Valley 10-meter data set. And shows up here in the map widget. And the model that I like to apply, this is just an equivalent model that you will construct if you use ArcGIS Pro, right? So this model takes a raster input, and there are multiple building functions I use here: slope, aspect, and some map algebra functions. So basically, what it's trying to do is I'm trying to make three conditions, to decide where is the best location for the vineyard. So I want to set a elevation value constraint that is larger than 30 and less than 400, and then I want to compute slope out of the elevation data set, and slope value has to be larger than 5, less than 60, and I want to compute aspect from the elevation data set. Aspect has to be larger than 10 and less than 200. I add all the scores together, so if I have a 3, that means location is best for building the vineyard. So to actually apply the functions, individual functions, and construct function chain is, again, really simple, right? We have every function ported to ArcGIS API for Python as methods. So by applying a function, you just call that method, right? This is the slope function that I want to apply. I just call the slope method. And all these methods are under the functions namespace. And I just call the slope method, give the input layer, elevation input, and give some additional parameters if there's anything you want to set. And I do another aspect, apply another aspect function. So every output of those functions can become the input for another function. In the next statement that I have here, I simply just feed the output of the slope function to this map algebra function greater than, and to find the pixel, to filter out the pixels that is greater than 5. Similarly here, I want to find the pixel that is less than 60, and I do a Boolean AND, right? And then similarly for aspect, I want to set a condition as well, larger than 0 and less than 200. And for elevation data set, I want it to be greater than 30 and less than 400, right? With all these 3 conditions output, and I can simply use the plus sign to add all of their pixel value together. So the operator are override in Python API. So when you're using the plus sign, it's actually just calling the map algebra plus function, right? And then I feed the output of all this plus operation into remap function, just remap the value of 0, 1, 2, 3 to the 8-bit pixel range so that I can apply a color map function on top of it. As you can see, by feeding the output of a previous function to the next one, I was able to build a chain of analysis. And the final output is this result layer that I can just directly add into the map. I don't think I have executed all this yet, so I'm not going to do this. And last one. Again, by just applying the function, adding the result layer to the map, this is just generating the on-the-fly previewed result, right? This is on-the-fly in-memory layer. This is not yet a persisted output image service in your portal. So in order to generate the final data product, what you need to call is simply the save method, right? So have the function result object and call the save method and decide what kind of output names you want. Behind the scene, you are calling the raster analysis services, system services to generate the output distributedly, right? So while we were waiting, I actually have a result generated previously. Then I can just add it back to the map. So as you can see here, in this statement, I'm just searching for the data, the contents that I have already published in my Enterprise GIS, and I can add it to the map, or not. Okay, let me find the previous one. Right. So basically, this is the idea of how you can use the Python API, ArcGIS API for Python to do the similar things that as you can do in ArcGIS Pro, construct custom function chain, call the building analytic functions. So this item is being generated, and although it looks the same, but it's actually a hosted image service in my portal. I think we still have a couple minutes. So will you guys be interested in looking at the REST demo? REST API demo? Yes? Okay. So we talk a lot about our front end, about the client, where you can construct functions and consume raster analysis services through all these interfaces. And I like to go behind the scene and show you what are the services that actually doing this job. So if any of you here actually deploy servers, yeah? a few. But if you're doing develop server, I hope after this session you go back and you can try to utilize this new functionality and deploy your own server to do raster analysis. If you deploy a server, then if you go to the system folder, you see this 3 new services that we had under this folder: the raster analysis tools, GP service, a raster processing service, and raster rendering services. So these 3 services are essential system services that supports the distributed raster analytic workflows. So if you go into the REST API page of the system raster analysis tools, you can see all these different analytic tools that we are building to this toolbox, among which the generate raster tools is the one that can actually take in a raster function as input and then generate the output using the function and the input information that you give it to the function. And as Mike mentioned earlier, I don't know if you caught that the raster function can actually be described using JSON as well. So we have a help topic here that explain in detail how you can transform a raster function template rf.xml file into a JSON representation, right? So essentially, if you are web developers and when you develop your own web app, let me just go back here, and you can call. You don't want to use any client app that I showed you earlier. You can just go into the REST API and design your own raster function template using JSON and specify the output and giving some argument values. Then the service will do the same thing as of generating output automatically in the distributed raster store and automatically publish the output imageries as image service in your portal. Right. So I do have an example here that I want to show. That is a JSON representation of a function chain that does a clipping on a elevation data set and then perform hue shade on the clipped DM image, digital elevation image. So the way I'm calling the REST API is just giving the entire JSON string of the function, right, to the raster function inputs, and then specify the output service name. It has to be changed to, and give the input service names. Again, you can find a really detailed docs explaining all the syntax about how you can invoke this REST API. And just click a submit jobs. This is like just calling any GP services, right? And then what you get in response is the URL that points to the image service that you created using this function template. Right. So that's everything I had to show today.
So just a note on that, like typically that's not how you use REST, right? That's just him demonstrating it through the HTML page of the server. The way you would really use all that would be code, right? You'd have a JS file and you'd write JavaScript code and you'd do it all through, HTTP objects inside of JavaScript, et cetera, right? So that just helps demonstrate the format of how you send things and whatnot.
Yeah.
So we have
5 minutes.
We have about 4 or 5 minutes. Are there any questions about things? Okay.
I'm wondering what the GPU requirements are for, this Raster Analytics.
It's not dependent upon GPUs.
Okay.
You don't have to have GPUs. It'll run completely on CPUs if you want CPUs.
That's great.
It will use GPUs, the Raster Analytics server?
The server will not.
The server,
right? The Pro, there are cases where the local processing will.
May I ask why are you asking whether we use GPU or not? Are you thinking about like deep learning, machine learning workflows? Or?
Well, I'm thinking about virtualization and the limitations on GPUs in a virtualized environment.
Ah, okay. Yeah. So there are actually, I'm not going to talk about deployment of the Enterprise GIS with Raster Analytics capability tomorrow at the same time frame in a room next door.
1 o'clock.
Yeah. So there are actually, if you're looking to deploy machines with powerful GPUs, the cloud platforms like Amazon or Azure actually has very good options. Yeah, you can even use them for machine learning workflows. Yeah.
I would say the other thing is don't assume that GPUs speed up everything.
Yeah.
There are many cases where these analytics run very fast on CPU-based VMs. Yeah.
Please talk about how third-party libraries are treated in Python and Raster functions and what they should do.
Yeah. So if I understand correctly, you want to know how you can apply Python Raster functions in this distributed environment?
Yeah, with extra libraries.
Right. So
with extra libraries.
How do you get the full Python? If your Python Raster function uses X number of libraries in the ecosystem, how do you get them on the server?
Yeah. So it's actually a bit complicated to explain that clearly. So I have a example of Python Raster function here. This is actually one of the built-in Python Raster functions that we have that you can just get it in ArcGIS Pro, current release of ArcGIS Pro. So if you have additional library other than the one that we include in our version of Python, right? There is a way to just install those packages, right? So are you familiar with the Python that comes with ArcGIS Server? Yeah, that's installed under C Python 2.7, and it's still using the 2.7.14 Python. And through using that Python, you can use either pip or conda actually to install extra packages. But in order to use these modules that you want to use in your custom Python Raster function, you have to install all these additional modules that does not come with server on each server node. But as of nowadays, if you have a server cluster that contains 4 machines, we actually didn't have a deployment story for you to just click a button or go through a publisher wizard that we automatically install those packages for you. You actually have to log on to every server machine on your server cluster and run the Python pip install to install those modules. Yeah.
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 So just make sure you do it for every instance, for every machine that has image server in the image server site. You have to do the pip install, the Python install.
Yeah.
Yeah. Anything else?
Anything?
All right. Thanks for coming.
Thank you very much for coming. Thank you.